Hello everyone, welcome to the course on data structures and algorithm. In this particular video we are going to see the stack implementation using linked list. We have already seen a simple stack wherein we keep on inserting all the numbers from one end. Like let's say I'm inserting 10 first, so top is pointing here, then I'm inserting 20, then top has been incremented to this place, then 30, then 40, and accordingly the top will be pointing to the very topmost element. If I start counting from 0, 1, 2, 3, then after inserting this 40, my top will be 3. So insertion is done from one end and deletion is also done from one end. And as we know, in our previous videos on stack, we have seen that insertion to the stack is known as push, whereas deletion is known as pop. So this particular concept we wish to implement, but we wish to implement using linked list. So the linked list, the normal concept of linked list goes something like this. We have all the nodes, the very first node pointing to second node pointing to third node pointing to fourth node, and likewise. So if I keep on putting some numbers 10, 20, 30, 40, 50, then in that case 10 will come first, then 20, then 30, then 40. Alright, so this is the normal scenario. Now let us see all this stuff one by one. So this is my scenario of stack, wherein pushing and popping is done from one end, and suppose in this particular stack we are having those 4 data, and the normal linked list looks something like this. I'm having the start pointer which is pointing to very first element, and supposing the address of very first element is 1000, that means the contents of the pointer start is 1000. Then the address part of this, the link part, the next part of this first node, this is my first node, so that contains address of second node. That means first node is point to second node. Likewise, the address part, the link part, the next part of second node, this is my second node, that contains address of third node. So I can say that second node is pointing to third node, and likewise the third node contains the address of fourth node, that means it is pointing to fourth node, and fourth node is last node in this example, so it is not pointing anywhere, so it is null. So this is the normal scenario. And now if I start printing, so I'll start from this place, so I'll first print 10, then 20, then 30, and then 40. So this is what I am going to get in case of this linked list. So in case of linked list, if I print them, then I am going to get 10, 20, 30, 40. But in case of this stack, if I print, I know that I'll get the topmost element first. So I'll get 40 first, then 30, then 20, then 10. So in case of stack, I am going to get 40, 30, 20, 10. So you can see the difference between these two. In linked list I am going to get 10, 20, 30, 40, and in stack I am going to get 40, 30, 20, 10. So anyhow, I need to modify my linked list in such a way that rather than 10, 20, 30, 40, I should be getting 40, 30, 20, 10. So if I can get this is pretty much similar to my stack way. So now let us see how can I change it. So rather than this, if I have a linked list like this, wherein the first pointer pointing to second one, if my second node points to the first one, rather than second pointer pointing to third one, if my third node points to second one, and if my fourth node points to the third one. So if I can create linked list like this, then in that case I can always start from this last node, and then I can always move to third node. So I will be printing 40 first, then 30 second, then 20 as a third place, and lastly I'll be printing 10. And this will be nothing but my stack weight, 40, 30, 20, and 10. So in short, now rather than this normal thing, now we want to create a linked list which should look like this. So in short, the first pointer pointing to next the next should point to first. This is the only difference that we wish to implement. All right, so now let us see how we can implement this difference. So let us move this. So initially the stack is not having any node. So when I insert the very first node, when I create the very first node, this is my first node, right? And then what I'll be doing, of course I know there are two things. The first one is data, and second one is contain the link, or what you call it address, or we call it next, or sometimes we call it previous. These are all the different names that we give to this pointer. So for first node we are going to set this as null, because we know that this is going to be the last one, because in stack we have last in but first out. Stack follows LIFO. So because this has been pushed first, this will go in last. So if you compare this with stack, this 10 will go in the last. Alright, so that is why we have made that as a null. Now what if I am having a second node? So second node is created like this. I am going to put some data into it. So data is 20, and the address part contains address of first node. So address of first node is put in the second node. That means now second node is pointing to first node. In our previous example we used to put this over here. Alright, so we used to have a scenario like this, the first node pointing to second node. But in this case we are having address of first node in the second node. That means the second node is pointing to first node. Now supposing I am having third node. So in that case the address of second node will be stored in the third node. That means the third node is pointing to second node. And I can always keep on incrementing the top. Initially the top was having 1000. That means the top was pointing here. Alright, when I am having second node, the top is pointing to second node. So top is now 2000. Top is now 2000, which is nothing but address of second node. When I am having third node, the top is pointing to the third node. That means the address of third node is 3000. And now if I am having the fourth node ready with us, so I can always store the address of previous node, third node, into the fourth node, and I can say that fourth node is now pointing to third node. In this case the top has moved to now recently added, this latest added block, which is nothing but the 4000 address. So at the end this is the scenario. So we will start from top. So if you compare this with our normal stack, you can see the very first node inserted was 10, so 10 is over here. Then second node inserted was 20, so 20 is over here. Then third node inserted is 30, so 30 is over here. And the last node inserted is 40, so 40 is here. Alright, and now this is nothing but my top is pointing to. So if I print this top arrow data, I am going to get 40. And now if I move to top this, that means once the data is popped, you know that if I pop this one, what will happen? If I pop this one, then this top, the value of top will be now pointing to the second node. So in that case the top will be over here. So this top will be moved to this place. So and second I'll be printing 30, then I'll be printing I'll be moving top to second, so I'll be getting 20, and lastly I'll be moving top to the last element, which is 10. And then now because this is null, it will stop there. So this is my terminating condition. But meanwhile 40, 30, 20 and 10, that these four different elements have been stored, have been printed in my output. So this is how you can do it. So let's see how can I do it programmatically. So programmatically, you know, my program, the main program would look something like this. I'm having a node with two members. As we know, there are two members. One is the data itself, so that is my data member, and other is my previous the address part. So that is nothing but my previous one. Alright, and I am going to have one top pointer which is initially null. Initially null means initially the stack is empty. Initially stack is empty. So how do I check whether the stack is empty or not? So if top equal to null, the stack is empty and there is no single data element in the stack. Now I am pushing 10, 20, 30, 40. So if I simply compare with the regular one, okay, what will happen? So I will be having first 10 inserted, then 20 inserted, then 30 inserted, and then 40 inserted. And after this point, after inserting 10, 20, 30, 40, my top should be over here on the element number 40. And then, but in this is the regular stack scenario. If I have to do this with linked list, it would look something like this. I am having 10 first, then 20, then 30, then 40. Alright, and this fourth element is pointing to third is pointing to second is pointing to first, and first is null, and my top is over here. So I am going to make this push function in such a way that it should create this type of linked list. So once these 4 elements have been pushed, and when I display, it should display 40, 30, 20, 10, because 40 is because stack follows LIFO. LIFO means last in first out. So who came last? 40. So 40 will come first out. Then if I make a pop, I know that the pop means the topmost element. So topmost element was 40. So 40 will be removed, and then if I make a display, then except 40, 30, 20 and 10 will be displayed. And now I also want to make one peep function, which is nothing but it will just give you the element which is being pointed by the top pointer. Means in short, the topmost value will be given by this peep. So this peep will give 30. It will not remove it because pop removes, but peep does not remove, it just displays. So in and all, this is the complete main function. So what do I need to do now? I need to make all these functions. The first function is push with some integer element, now next function is pop, wherein I am not going to pass anything because I know I'll be deleting the top only. The display function, I'll be printing everything from top, like 40, 30, 20, 10 likewise, and peep, which will be printing the topmost element only. Right, so I wish to create all this function. So you can see push is a very simple function, like for example push, and then I'm having item like 10. Okay, and initially I know that top equal to null, So now what am I going to do? Struct node star new node. So I am going to create a structure with 2 members. One is data member, other is the previous pointer. We use the word previous here. Alright, and let's say this one is new node. So new node, and we can also assume some address, let's say 1000. Okay, so now this data item 10, now this item 10, that is stored in new node arrow data. So this is nothing but new node arrow data, and new node arrow previous equal to top. So what's the value of top? Top equal to null. So that null is stored in the previous part. So this is nothing but null. And then new node equal to top. So now this is my new top. Earlier the top was null. Now my top is 1000. So this is when I call this function first time. Then second time, if I call this again, let me erase all this stuff. So second time when I call this again, it will create another node. With the same variable new node. So let me delete new node from the first one. So now if I create another node, so this is my new node. This is my new node, and again it is having two members. One is data member and other is previous member, and for example the address of this is 2000, and this time I wish to add 20, so that 20 would be going into new node arrow data. So this is new node arrow data 20, and new node arrow previous equal to top. So what's the value of top? 1000. That I am going to put it in new node arrow previous. So new node arrow previous, this will be 1000. So the moment I put 1000, I can say that this is pointing to this location, and then this new node, that is 2000, is put in top. So now earlier top was 1000, now top is 2000. So I am moving the top also, because we know in stack when you insert something, the top is incremented automatically. So the top is incremented. So this is done. Now let's add one more node so that you will have better idea. So if I call this again, if I call this function again with, let's say, item 30, then again this will create a node which is being pointed by this new node. So new node is pointing to a newly generated node with two items, data item and previous item. And for example, the address of this one is 3000. So now then I am going to put this 30 into new node arrow data. So 30 will go in new node arrow data, and this top, what's the value of top? 2000. So that 2000 is put into new node arrow previous. So this one is new node arrow previous. So over here I am going to store 2000. That means it is pointing, the third node is pointing to second node. And lastly, I will be assigning the value new node, that is 3000. New node is 3000, that is copied into top. So earlier top was 2000, now top is 3000. So now that means top has been moved to the third position. So this is how you keep on incrementing. This is how you keep on incrementing all this. Then likewise you can have 40, 50, 60, all those nodes added. The only thing which is important to note here is the value of top, which is getting incremented. Alright, so if we compare this with our regular stack, you know that initially if you have only 10 in the stack, the top is pointing here. When you insert 20, then the top is pointing here. In that case this is gone. When you insert 30, the top is pointing here. In this case this is gone. Alright, so we can see that initially top was over here, then it was here, and now latest top is over here. So this is my push function. Second is pop function. So in case of pop, what do? Supposing you have this list, suppose we have already created this list just now. So assume that we have this list ready. I'm having 10 here, I'm having 20 here, I'm having 30 here. Now this is you can have some addresses like 1000, 2000 and 3000. Alright, and now this is pointing to this, means it contains address of the second node. This is pointing to this, that means it contains address of first node, and this is not pointing to anywhere, that means it contains null, and my top is over here. Now when I use this pop, it should be displaying me 30 as well as it should remove. So remove means you will be freeing. So for that you need a temporary variable. Alright, so what you are going to do, you are going to have a temporary variable, and which will be set to top. So temporary is set to top. So temp and top both are pointing to the latest, the last node added, which is 30 in this case. Now we are checking if top equal to null, because if the stack is empty you cannot pop. Alright, so if it is null, you can simply display the message stack is empty and return. But if there is a message, what are you going to do? You are going to move this top. So you are going to move this top to top equal to top arrow previous. So you are going to move this top, because once you know this is 10, 20 and 30. So when I remove 30, so earlier the top was over here, so then top should be moved to the next place. So now I am moving the top to the second place. And then what should I do? Second part is I should be freeing up this memory. So second part is, so first I do top equal to top arrow previous. So this is my first one, and freeing up this, the crossbar is my second part. So I'll be freeing using temporary pointer because I already set a pointer temp over here. So that's it. This will be just by two statements. Effectively there are two statements. You are moving top to the previous, the second last value, and then you are freeing the topmost value that you have just popped. Just by these two statements it is done. Now second is pip. Now in this pip, of course we are going to check whether the top is null or not, because if top is null there is no element in the list, so there is no point in pip function. Alright, so in that case, if it is the case, we will just simply put the message. But if it is not the case, suppose there are some elements in the list, in that case we will be just printing in top arrow data. That's it. We will not move this top equal to top arrow previous. Why? Because in case of pip we are not removing, in case of pop we are removing. Alright, so removing matlab you are going to set the pop to previous value, at the same time you are going to remove the memory also. Over here you are not going to use free, you are not going to use top equal to top arrow previous, simply you are going to print the value. That's it, and this is done. And in case of display, as we know, in case of display it is very simple. Supposing you are having this 4 different nodes starting from the first to last. Let's say again 10, 20, 30, and let's say this one is 40, and 40, this is nothing but your top. So this previous is pointing to this one, this previous is pointing to this one, this previous is pointing to this one, and this is null. So what you do, you start a temporary from the temp. So we will be having a temporary variable which we will start from top, and every time I will print temp arrow data. So temp arrow data, initially this one is 20, and then I move temp equal to temp arrow previous. So now this temp is moved to this place. So second time when I print temp arrow data, it will print 30. Then again I move temp equal to temp arrow. So now temp is at this position. Now when I print temp arrow data, so this time it will print 20. Then again if I move temp, so it will be over here, and last time it will print 10. So 40, then 30, then 20, then 10. All elements are printed. And then if I do temp equal to temp arrow previous, it will be null. And this is my terminating condition. If temp is not equal to null, then keep on doing, but if temp is null, then done. So at that time we will come out of this loop. So display is a very simple function, and this output we have already discussed. This is as per our main function, wherein we inserted four elements, 10, 20, 30, 40. Then we removed 40, means we used pop, then we used pip, and then display. That's it. So this link in the bottom is nothing but the program code for this particular program, the entire program. And now I guess this is done. In this video we have seen how to implement stack using a linked list. So thank you very much students for having with me, and in next video we are going to see how to implement queue using linked list. So thank you guys.